Hi everyone, good morning. I am Swetha, Assistant Professor from the Department of Artificial Intelligence and Data Science at Vailtech Multitech Dr. Rangaraj and Dr. Shakatala Engineering College. Welcome to today's lecture on UML. Let's move on to the presentation. First, we are going to see what is UML. UML stands for Unified Modeling Language. It is a structural visual modeling language used to design and describe the structure and behavior of a software system before writing code. UML is a graphical language for visualizing, specifying, constructing, and documenting the components of a software system. It helps software developers and analysts understand how the system works, what components it includes, and how they are interacts. Next, main purpose of UML. First one is to visualize system architecture clearly. UML provides diagrams that helps you see how a software system is built. It shows the structures like classes, modules and components and the connection between them. So instead of reading long code, you can easily understand the system just by looking at the diagram. The next one is to communicate ideas among developers, designers and stakeholders. UML act as a common language for everyone involved in the projects. Using diagrams, everyone can understand the system flow and design clearly, even if they are not programmers. This improves team coordination and reduces misunderstanding. The next one is to analyze and design object-oriented softwares. UML is mainly used for object-oriented analysis and design. It helps to identify the objects, their attributes, methods, and relationship before actual coding begins. This ensures the system design is well structured, reusable, and maintainable. The last one is to document the system for future maintenance. UML diagrams serve as a documentation for the entire software. Even after years, new developers can look at these diagrams to understand how the system works without reading all the code. It helps in debugging, updating, or adding new features later. Next, types of UML. There are mainly two types, structural diagrams and behavioral diagrams. Structural diagram shows the static structure of the system. It shows classes, objects, components, and their relationship. There are 7 types of structural diagrams. Composite structure, deployment diagram, package diagram, profile diagram, class diagram, object diagram, and component diagram. The second type of UML diagram is behavioral diagram. These diagrams show how the system behaves or how different parts of the system interact with each other when the program is running. In simple words, structural diagrams shows what the system has, but behavioral diagram shows what the system does. Behavioral diagram helps us understand the flow of activities, communication between objects, and reaction of the system to different input or events. Next, we are going to see the types of behavioral diagram. There are 7 main types of behavioral diagram, that is state machine diagram, communication diagram, use case diagram, activity diagram, sequence diagram, timing diagram, and interaction overview diagram. These diagrams helps developers understand how the system works dynamically, step by step. Next is use case diagram. A use case diagram is a type of UML diagram. It represents the interaction between actors and the system. It provides a high-level view of system functionality by illustrating the various ways user can interact with it. Next is components of use case diagram. The main components of use case diagram is actor, use case, system boundary, and association. Let's see one by one. First, what is an actor? An actor represents a user, role, or external system that interacts with your software. Each actor performs some action with the system, like making a payment, buying products, etc. The second one is use case. The use case represents a function or task the system performs when an actor interacts with it. Each use case should deliver some value or result of the actor. In a diagram, it is shown as an oval. The third one is system boundary. The system boundary defines the scope of the system. It explains what is inside the program and what is outside the system. It is shown as a rectangular box enclosing all use cases. Everything inside the rectangular is a part of software system being developed. The fourth one is association relationship. It represents a communication or interaction between an actor and use case. Here is an example of a use case diagram. This diagram shows how a customer interacts with the ATM system and what kind of operations can be performed through the ATM. It also shows how the bank server is involved in the process. First, the customer inserts their card into the ATM. Next, the system performs authenticate user by checking with the bank server to verify the card and PIN. Once authenticated, the customer select the type of transaction. For example, withdraw, deposit, checking balance, etc. Then the selected use case is executed. For example, if the user chooses withdraw cash, the system connect to the bank server to check balance. If everything is fine, cash is dispensed. Then the system prints a receipt. After completing the transaction, the system returns the card and display the thank you message. Next is class diagram. Class diagram visually represent the structure of the system by showing its classes, attributes, methods, and the relationship between them. It helps everyone involved in a project, like developers and designers, understand how the system is organized and how its components interact. It also helps to communicate and document the structure of the software. Each class is represented by a rectangle. It is divided into three components: name, attributes, and operations. Modifiers are also used to indicate visibility of attributes and operations. There are three modifiers used: public, protected, and private. By default, attributes are hidden and operations are visible. Next is class diagram relationship. In class diagrams, relationship between classes describes how classes are connected or interact with each other within a system. The most common relationship is composition. Composition is a stronger form of aggregation, indicating a more significant ownership or dependency relationship. Composition is represented by a field diamond shape on the side of the whole class. Next, directed association. A directed association in a UML class diagram represents a relationship between two classes where the association has a direction, indicating that one class is associated with another in a specific way. Next is usage relationship. Usage dependency is a special type of dependency that shows one class use or relies on another class to perform certain actions. Fourth one is generalization. Generalization is also called as inheritance. It shows an is a relationship between two classes. Next is aggregation. Aggregation is a specialized form of association that represents a whole part relationship. It denotes a stronger relationship where one class contains or is composed of another class. Aggregation is represented by a diamond shape on the side of the whole class. In this kind of relationship, the child class can exist independently of its parent class. Next, association. An association represents a bidirectional relationship between two classes. It indicates that one class are connected to another class. And then dependency. A dependency means that one class depends on another for some work, but they are not tightly connected. The relationship is temporary or indirect. The final one is realization. Realization shows that a class implements an interface. The class agree to perform all the operations described in that interface. Now, let's see an example of a class diagram. The class diagram is divided into three main components: name, attributes, and operations. The name of the class is typically written in the top compartment of the class box, and it is centered and bold. And then the attribute, it is also known as properties or fields. It represents the data members of the class. They are listed in the second compartment of the class box and often include the visibility, for example, public, private, and the data type of each attribute. The final one is method. Method is also known as function or operations. It represents the behavior or functionality of the class. They are listed in the third compartment of the class box and include the visibility, return type, and parameters of the each method. Visibility notations indicates the access level of attributes and methods. Common visibility notations include public, private, protected, and package or default visibility. Next is benefits of class diagram. First one is easy system visualization. Class diagram helps us clearly see how different parts of the systems are connected and interact with each other. The second thing is improves code structure. They provide a clear blueprint for developers, making the code more organized and easier to understand. The third one is supports reusability. Common classes can be reused in different parts of the system, reducing repetition and saving time. Final one is simplifies and maintenance. When the system needs changes or updates, the diagram makes it is easier to identify what parts are affected. Next is activity diagram. Activity diagram are an essential part of UML. It helps visualize workflows, processes, or activities within a system. It also explains how different actions are connected and how a system moves from one state to another. By offering a clear picture of both simple and complex workflows, activity diagram make it is easier for developers and stakeholders to understand how various elements interact in a system. An activity diagram starts from an initial point and end at a final point, showing different decision paths along the way. They are often used in business and process modeling to show how a system behaves over time. Next, when to use activity diagram. Activity diagrams are useful in several scenarios, especially when you need to visually represent the flow of processes or behaviors in a system. Here are key situations when you should use an activity diagram. The first one is modeling workflow or processes. When you need to map out a business process, workflow, or the steps involved in a use case, activity diagrams helps visualize the flow of activities. The second one is understanding the dynamic behavior. When it is essential to explain how a system changes over time and moves between different states based on events or conditions, activity diagrams are effective. The third one is clarity, complex logic. Use an activity diagram to simplify complex decision-making processes with branching paths and different outcomes. The fourth one is system design and analysis. During the system design phase of a software system, activity diagrams helps developers and stakeholders understand how different parts of the system interact dynamically. And the final one is describing use case. They are useful for illustrating the flow of control within a use case, showing how various components of a system interact during its execution. Next is activity diagram notation. The first one is initial state. Initial state is also known as start state. It is the first and most important element in an activity diagram. It represents the starting point of a process. Every activity diagram begins with one initial node, which marks where the flow of actions or operations starts. It helps the reader understand from which steps the user activity begins. The second one is final state. The final node is also called as end state. It is used in an activity diagram to represent the ending point of a process. It shows where all the activities come to a stop and the process reaches its completion. The final node indicates that the flow of control has finished and no further actions will occur after this point. The third one is activity or action node. It is one of the most important element in an activity diagram. It represents a specific task, operations or steps that need to be performed as a part of process. Each action shows a meaningful piece of work done by the users. In simple terms, an activity node answers the questions: what happens in the step? It is drawn as a rounded rectangle that is oval, and it is usually connected by arrows to show the order of execution. Activity nodes make the workflow easy to understand because they break the overall process into smaller manageable steps. Each action is connected by control flows showing the sequence in which actions occurs. An activity can also involve decisions, parallel operations, or interactions with different actors. The next one is decision node. Decision node is an activity diagram that helps to show choice or conditions within a process. It is used when the workflow can flow different paths based on a decision or condition. In simple terms, a decision node represents a point where the system or user must make a choice. For example, yes or no, true or false, or pass or fail. The symbol used for decision node is a diamond shape, and it is usually followed by two or more outgoing arrows, each labeled with a condition written inside square brackets such as valid or invalid. The main purpose of decision node is to control the flow of the activity based on the outcome of a condition. When the control flow reaches the decision node, the condition is evaluated and the process continues along the path that satisfies the condition. This helps to represent logical branching in a process, making the diagram more realistic and meaningful. Next is fork node. The fork node is an activity diagram is used to split one flow into multiple parallel flows. It represents a point in the process where several activities can occur at the same time instead of one after another. The fork node helps to model concurrent or parallel processing, something that happens in real-time systems where different tasks can run simultaneously. It is drawn as a thick horizontal or vertical bar with one incoming arrow and two or more outgoing arrows. The main purpose of fork node is to show that one activity divided into several independent activities that can be performed at the same time. Each outgoing flow from the fork node represents a separate parallel path. These parallel activities may later be joined together using a join node when all the tasks are completed. The join node is an activity diagram is used to combine two or more parallel flows into a single flow. It represents a point in the process where multiple activities that were running simultaneously come together before continuing as one. In simple terms, a join node means wait for all parallel tasks to finish before moving to the next step. The main purpose of join node is to synchronize parallel activities. When several actions are happening at the same time, the join node ensures that the process will not move ahead until every parallel task is completed. This helps to maintain proper coordination between different parts of the system. It ensures that no step is skipped and that the next activity only begins when all the required previous activities are done. Final one is control flow. The control flow represented by an arrow is one of the most basic and essential notation is an activity diagram. It is used to show the direction or order of activities within a process. The control flow connects different nodes such as activities, decision, merge, fork, and joins. In simple words, it tells us which activity happens after another. Without control flow arrows, the diagram would just be a set of isolated steps with not clear sequence or meaning. This is an example of activity diagram for train ticket booking system. This diagram clearly represents the sequence of activities in a train booking system, starting from searching a train to printing the ticket, and helps developers understand the workflow easily. This diagram shows the complete workflow of actions that happens when the user books a train ticket online. The process starts when the user opens the application. First, the user search for a train by entering the source, destination, and travel date. Next, the system checks the ticket availability for that particular train. Here, there is a decision point. If no tickets are available, the user will be directed to log out and the process ends. But if the tickets are available, then user can continue with the booking. Then the user books the ticket, fills passenger details and submit the details to the system. After that, the user moves to the payment step where they can pay through online modes like debit card, credit card, or UPI. Once the payment is successful, the system allows the user to print or download the ticket. Finally, the process ends successfully after ticket generation. Next is sequence diagram. A sequence diagram is a type of UML that shows how objects interact with each other over time. It is mainly focused on the order of messages exchanged between different parts of a system to complete a process. The main purpose of sequence diagram is to show how messages flow between objects to carry out a specific function or process. It helps developers and designers understand the dynamic behavior of a system, making it easier to visualize how operations are executed step by step. Next is why use sequence diagram. Here are some key reasons for using sequence diagram. The first one is visualizing dynamic behavior. Sequence diagrams explains how objects interact with each other in a sequential manner, making it easier to understand dynamic processes and workflows, and then clear communication. They provide a clear way to convey system behaviors, helping teams understand complex interactions without dividing into code. And then use case analysis. Sequence diagrams are useful for analyzing and representing use cases, making it clear how specific processes are executed within a system. The fourth one is designing system architecture. They assist if defining how various components or services in a system communicate, which is essential for designing complex distributed systems or service-oriented architectures. And then fifth one is documenting system behavior. Sequence diagrams provide an effective way to document how different parts of a system work together, which can be useful for both developers and maintenance teams. The final one is debugging and troubleshooting. By modeling the sequence of interactions, they help identify potential bottlenecks, inefficiencies, or errors in system processes. Next is sequence diagram notations. In a sequence diagram, several notations are used to represent the interaction between different objects in a system. The main notations include actor, objects, lifeline, messages, activation bar, and interaction frames. An actor represents an external entity such as a user or another system that interacts with the application, while an object represents a component or a class within the system. Each actor or object has a lifeline, which is shown as a dashed vertical line indicating its existence over time. The messages are represented by arrows between lifelines and show the flow of communication or function calls. There are three main types of messages. Synchronous messages, that is where the sender waits for a response, and asynchronous messages where the sender does not wait and return messages. It is represented by dashed arrows showing control returning to the sender. And then the activation bar is a thin vertical rectangle placed on a lifeline to indicate the period during which an object is performing an operation or is active. The interaction frame are used to represent conditional and looping behavior. For example, if-else conditions, looping conditions for optional process. Finally, a destroy message shown with an X symbol represent the termination or deletion of an object at the specific point. Together, these notations provide a clear understanding how different components communicate and the sequence of actions in a system. Thank you.